Now we're going to take up one more problem, the problem number 28. For the beam shown in figure, draw the SFD and BMD and locate the point of contra flexure, if any, for the overhanging beam. So you can see there is a overhanging beam wherein the overhangs only between D and E for a span of 2 meters. And at A and D, you have a reactions at the supports, which is RAV and RDV. Between A to B, you have UDL, and at the point B, you have 3 kilonewton, the UDL being 1 kilonewton per meter for a span of 2 meters. Then you can see at the point C, you have 4 kilonewton acting downwards, which is at a distance of 4 meters from A. And from C to E, you have a 2 kilonewton per meter for a span of 4 meters. And at the point D, you have a vertical reaction, which is RDV, which I need to find out the support reactions. To find out the support reactions, taking the moments about the point A, the clockwise couple will be equal to the counterclockwise couple. So that means RDV into 6 will be equal to, so you can see 2 into 4. So that means 2 into this entire length of the UDL, it is 4 into, open the bracket, 4 by 2, which is going to be the midspan, plus 4 and close the bracket, then plus 4 into 4, because from this to here it is 4 into 4, then plus 3 into 2, then plus 3 into 2, plus 1 into 2 into 2 by 2. So on simplification, you are going to get RDV will be equal to 12 kilonewton. Now also we know what is that the sum of the vertical reaction acting upwards will be equal to sum of the vertical reactions acting downwards. So RAV plus RDV will be equal to 1 into 2 plus 3 plus 4 plus 2 into 4. So therefore, RAV will be equal to 2 plus 3, 5 plus 4, 9 plus 8, 17 minus 12 will be equal to 5 kilonewton. So therefore, RDV will be equal to 5 kilonewton. So when it comes to the shear force diagram, so first we need to find out what will be the shear force at each and every point. SF at A is the positive as the taking the section toward the left to the left hand side, left up side of the section acting upwards is positive according to the Hayes convention. SF at A will be equal to plus 5 kilonewton. So SF at B, when you are considering SF at B, which will be plus 5 minus 1 into 2 minus 3. So plus 5 minus 1 into 2 minus 3 will be equal to 0. But what happens here at the point B, you have UDL and also the 3 kilonewton acting downwards. So first you are considering between A and B. SF between A and B, if you are considering it is plus 5 minus 1 into 2, 5 minus 2 becomes 3. So as we see, SF varies from plus 5 kilonewton to plus 3 kilonewton only because due to the consideration of the UDL. So according to the equation of straight line, because it is W into X, equation of straight line due to UDL, and then because due to, and then suddenly reduces to 0 because due to the point load at the point B. So then what happens? SF at C. So that is between B and C, as there is no other load is acting. So between B and C, it remains 0. What will going to be the point at SF at C? SF at C, as the 4 kilonewton is acting downwards, it will be minus 4 kilonewton. So 0 minus 4 will be equal to minus 4 kilonewton. Then SF varies from minus 4 kilonewton to minus 8 kilonewton due to UDL. So that you are going to get it in the next. SF at the point D will be equal to minus 4, then minus 2 into 4, which will becomes minus 8. So minus 4 into minus 2 into 2 plus 12, because that load acting at the point D is acting upwards, which will be equal to 12 kilonewton. So minus 4 minus 2 into 2 plus 12, which will be equal to 4 kilo minus 8 plus 4, which will be equal to 4 kilonewton. So we can describe here at the point C, you have minus 4 kilonewton. So then when you are considering at the point D only the UDL, then what happens? It will be minus 4 minus 2 into 2, it becomes minus 8. So that means SF varies from minus 4 to minus 8 kilonewton linearly due to UDL. Then what happens? Because due to the point load at the point D, it is acting upwards, it is become positive. So it becomes -8 plus 12. So it becomes plus 4 kilonewton. Then rises or then changes suddenly to plus 4 kilonewton due to the point load or the reaction at D. Then what happens to the SF at E? SF at V will be equal to plus 4 minus 2 into 2. It becomes 0. SF varies from plus 4 kilonewton to 0 because due to UDL. So that is how you can see here. This is the nature of the pattern. So SF at A is plus 5. SF at B with minus plus 3, it reduces to 0. Between B and C, it remains constant. At C, because due to the point load acting downward, it becomes minus 4. Between C and D, because due to 2 kilonewton per meter, minus 4 minus 2 into 2, it becomes minus 8. Because the reaction at the point D is acting upward, it is plus. Minus 8 plus 12, it becomes 4. Between D and E, it is minus 2 into 2 because minus 4 plus 4 minus 4, it becomes 0. So this is how the shear force analysis of shear force is done at each and every salient points. Now we will consider the bending moment diagram. So BM at A will be equal to 0. Then BM at B will be equal to plus 5 into 2 minus 1 into 2 into 2 by 2. So that will be equal to plus 8 kilonewton meter. Similarly, bending moment at the point C, which will be equal to plus 5 into 4 minus 1 into 2 by 2, it is at the center, and then which is at the point C, so 2 by 2 plus 2, so minus 1 into 2 by 2 plus 2, then minus 3 into 2, which will be equal to plus 8 kilonewton meter. Similarly, BM at the point D will be equal to 5 into 6, that will be plus 5 into 6 minus 1 into 2 by 2 plus 4, because with respect to D, this point is at a distance of, this point is at the midspan is distance of 4 plus 1. So 2 by 2 plus 4. Then we have minus 3 into 4, then minus 4 into 2, then minus 2 into 2 by 2. Then that will be equal to minus 4 kilonewton meter. Then BM at E will be equal to plus 5 into 8 minus 1 into 2 by 2 plus 6 minus 3 into 6 minus 4 into 4, then minus 2 into 4 by 2 minus 2 into 4 by 2 plus 12 into 2 will be equal to 0. So this is how. So in this case here it is minus 2 into 4. It should be not 2, it should be 4, because the length of the UDL here for the entire section is considered, which is for 4 meters. So minus 2 into 4 by 2 plus, because from this reaction it is acting upwards, it becomes sagging. So that is 12 into 2 will be equal to, on simplification, it becomes 0. So this is how you will going to have the bending moment diagram. So bending moment at the point A to B, as you have a UDL, so you have a parabolic curve. Between B and C, again you have, it is plus 8 and plus 8, it remains constant. Between C to D, plus 8, it becomes to minus 4, it comes down to minus 4. That means the bending moment is changing its sign from positive to negative. And since it is the UDL, you have a parabolic curve. Then from minus 4 kilonewton meter, it becomes 0. Again from D to E, it becomes 0. Since from D to E is also you have a UDL, therefore you will going to get a parabolic curve. So now we have the point of contraflexure. So what is the point of contraflexure? Where the bending moment changing its sign from positive to negative. So point of contraflexure, it is the point where the bending moment changes its sign. Let F be the point which is at a distance of x meters from E, where the bending moment changes its sign. Once it is changing its sign, you can see here the bending moment at the point F, the magnitude of the bending moment at the point F is 0, that will be equal to, so from this distance x is 0, that means it will be at that point minus 2 into x by 2 plus 12 into x minus 2. From plus 12 into x minus 2, on simplification, you will going to get it as x will be equal to 12 plus or minus root of 12 square minus 4 AC, that is minus 4 into 1 into 24 by 2 into a. So this is of the quadratic equation, the quadratic root. So you will going to get the distance as 2.536 meters from E. So this is how. So taking the smaller value, you will going to get that value of x as 2.536 meters from E. So this is how you will be able to analyze both the shear force and the bending moment diagram and also the point of contraflexure. So the point of contraflexure is at 2.536 meters from E. So this is how you will be able to solve this particular problem. Thank you.